Hello my friends, good night. Welcome to the Narcos Networking channel. My name is Luis Narciso. I'm a network and security engineer and I'm here today to show you how to enhance configurations regarding the BGP protocol in a multi-vendor scenario. For today, the day 99 of my 100 series, uh, notice that we are almost at the end. I'm going to address an issue that we had on the previous video. It was regarding the routes that were present on the Palo Alto towards the Juniper loopbacks 5.5.5.6 and 5.5.5.7. They were present on the Palo Alto FIB, but they were leaving the Palo Alto via the MikroTik autonomous system 65,000. And not via the external BGP multi-hop process that we have configured with the Juniper device on the autonomous system 65005. Uh, the same issue is occurring on the Juniper device because it is choosing the MikroTik autonomous system 65000 instead of the Palo Alto autonomous system 65003 when sending the traffic towards the Palo Alto loopbacks 3.3.3.4 and 3.3.3.5. The Palo Alto is also not propagating the routes towards the Juniper device. And we can go and check that on our Juniper device. Okay, we are in command line interface, and now we are going to configure and run show route received protocol BGP, and we are going to say that our peer is the Palo Alto 123.32.32, and let's see what we are receiving here. So as you can see, we are receiving, let me put this bigger, and let me run the command again. Okay, now we can see it better. You can see that we receive from the Palo Alto all these routes from the autonomous system 65003, but notice that we only see the route 3.3.3.3. So we need to get here on this process also the 3.3.3.4 and 3.3.3.5. Uh, let's see which routes we receive from the MikroTik. Let's run the same command but with the MikroTik neighbor 25, 52, 25 if I'm not mistaken. And here we can see that we received the 3.3.3.4 and 3.3.3.5 via the MikroTik, and this is not what we need. So we are going to fix this issue. But first, let's configure the host name of the Juniper device because it deserves to have a name. Set system host name router Juniper 5. Okay, let's commit it. Okay, now we have a name on our Juniper device. Now what are we going to do? We are going to go to the Palo Alto. Where is the Palo Alto? Here you are. Let's enter. Okay. And now on the Palo Alto, we are going to start with the advertisement of the routes towards the Juniper. Uh, 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 but first, I believe that we have configured the loopback addresses um, without the slash 32. So let's place the slash 32 on them. Let me put also this bigger. Now, let's verify that what I am saying is true. Show network interface loopback units. Let's see. Okay, as you can see, we only have the /32 for the 3.3.3.3, and for the others, we have uh, uh, 3.3.3.4 without the /32 and 3.3.3.5 without the /32. Let's change this. Set network interface loopback units loopback.4 IP 3.3.3.4/32. And now we are going to delete the other. Let's do the same for the .5. And let's delete the other. Now if we do again a show for these, now we are in the right shape. Okay, now to receive the routes on the Juniper device, the Palo Alto must advertise and export the routes with redistribute and export rules. So let's configure the redistribute rules. For that, we are going to use the command set network virtual router PA-VR protocol BGP redistribute rules, and let's redistribute 3.3.3.4/32. We are going to say that it belongs to the address family identifier IPv4. We are going to set the origin interior gateway protocol, and we are going to say that it is enabled. Let's check it. Let's copy these, Control C, Control L. Let's place a show and paste it. And here you have it. Okay, similar to the 3.3.3. Let's do the same for the 3.3.3.5. Okay, if we press the left arrow and then the right arrow, now we are going to see the command that we have ordered, and we are going to change this one to 5, and boom, it's done. Let's check it again. Okay, here we are. So regarding the redistribution rules, we are ready to go. But now we need to export them, and we need to export them to the Juniper device with this command. Set network virtual router, our virtual router for the protocol BGP, and let's create a policy. Policy export. Let's say that it is a rule, and the rule will have the name export loopbacks to Juniper, and it will be used by our peer, that is Multihop Juniper peer. Now we need to say that what it will match. Instead of used by, we are going to say that it will match what? Our address prefixes. and our address prefixes are the 3.3.3.4/32, and we are going to say that it is exact, and also the 3.3.3.5. Okay, now we need to give an action to this policy export, and the action, as you may know, it should be allow. Okay, now that it is allowed, what are we going to do? Uh, we are going to do a commit so that it can go from the candidate config to the running config. And after this, we are going to the Juniper side. No, we are not going to the Juniper side. We need to prefer the Palo Alto autonomous system. We need to prefer the Palo Alto autonomous system 65003 to exit. Yeah, that's it. We need to prefer the Palo Alto autonomous system 65003 to exit towards the 3.3.3.4 and the 3.3.3.5 instead of the MikroTik autonomous system 65,000. And for that, what are we going to do? We are going to change the local preference to 200, similar to what we have done on the Palo Alto side on the last video. And for that, we are going to Juniper, and we are going to configure set policy options, policy statement. Well, let me see something first. Let's see what routes are we receiving from the 123.32.32. Now you can see that we are already receiving the routes that we have configured on the Palo Alto. The commit is successful. If you see the 123.32.32, it's the interface from the Palo Alto. It's our neighbor. It's our external BGP neighbor, Multihop. So our command was properly configured. Now let's do the policy options in the policy statements to have the local preference manipulated to 200, because higher the local preference, higher the preference that the route will have, and for the default is 100. If the local preference for this route for the Palo Alto is higher, it will prefer the autonomous system 65,003. So let's configure it. Set policy options, policy statement. Let's give him a name. Prefer Palo Alto to MikroTik, and we are going to set some terms, and the term will have the name prefer Palo Alto routes, and we are going to prefer this from the protocol BGP. Okay, and now we are going to say that it is from the neighbor that is the Palo Alto 100.23.32.32, and we are going to say that with these statements in action, the local preference will be 200, and we will say that we are going to accept these terms. And we are going now to create another term that is a default term And for this default term, we are going to say reject everything. And then reject. Okay. Now we need to set these terms to the BGP group to which the Palo Alto belongs. So set protocols BGP group external BGP Palo Alto, and we are going to import these terms that is called prefer Palo Alto to MikroTik. Uh, let's see if it is properly configured. Show policy options, policy statement, prefer Palo Alto to MikroTik, and we have the terms prefer Palo Alto underscore routes. Okay, I did an underscore. Oh, no problem. It will work. We are saying that from the protocol BGP with the neighbor Palo Alto, then we are going to manipulate our local preference and accept it. And we have another term that is saying everything else reject. Okay, let's see our group. Show protocols BGP external BGP group. Okay, here we have here. Why am I using this command? I don't want to see this. Okay, let's go ahead. Let's commit. Okay, commit complete. Now let's see the routes that we are receiving from the Palo Alto. Run show route received protocol from BGP and our neighbor Palo Alto neighbor, it's 100 23 32 32, and as you can see we are receiving only the loopbacks. If we do the same for the MikroTik 125 52 25, we are also receiving the other routes. But as you can see, notice that we have the star on the routes received from the Palo Alto, and now the the routes received from the MikroTik don't have the star. So this means that the routes are preferred um, via the autonomous system 65003. Uh, Let me see what we can have, what I can see more. So as you can see from here, we have the route 3.3.3.4 received it as a star here on the autonomous system 65003, and our local preference is 200 compared to the route received via the autonomous system 65,000, uh, in which the local preference is 100. So for this part we are done. we have achieved our goal. Now we need to test the convergence interval in the BGP. The convergence interval in the BGP goes from 60 seconds to 180 seconds, more or less. And for that, we are going to use our MikroTik and our Palo Alto to verify. This is because what we are going to do next, and I will explain it in just a moment. For now, what I'm going to do is it's to let me show you. We have here this interface on the MikroTik that goes to the Palo Alto, and I am going to disable this interface. Disabling this interface, the BGP process will show established on the Palo Alto because of the time convergence of the BGP. Let's see it in action. So in the interface, Ethernet. No, it's not interface. It's interface set. How is it to disable the port? It's like this. Yes, Ethernet 3 disabled. Yes, but before I am going to run on the Palo Alto a command to see the routing protocol. Show routing. Oh, it's not here. It's here. Show routing protocol BGP peer name, and our peer name is D123.32.23, and as you can see we have here established. Okay, what we are going to see, it's when I disable the interface on the MikroTik, the process of the BGP will also say established because of the time reconvergence. So, boom, interface down, and we are seeing here established. Let's say that we are going to match peer status, and this it's yet saying established. As you can see, um, if we do a ping to the host 2.2.2.2 that is from the MikroTik, the route is not reachable, but we are seeing that the BGP process continues to say established. This is due to what I told you regarding the 60 seconds to 180 of the BGP convergence. Here on the MikroTik, routing BGP session sprint. What can we see here? We can see that it says also established, but it's not. Okay, now we see idle. Did you see the time that it takes to say idle? Now we have here a one, and here a one. No, it's the session number one on the session 0 to the Juniper we have the status established, but on the session to the Palo Alto it is not established. The flag E missed is missing here. So let's put again the interface in an up state, and Let's see again the process, and now we are seeing again established. And on the MikroTik side, the same should happen. Yeah, as you can see, now we have and again the flag. So as you can see, this is a lot of time to the BGP process to reconverge, and we have a tool um, that is called BFD, uh, and we are going to start the configuration of the BFD between the MikroTik and the Palo Alto. But first, let's talk a little bit about BFD. BFD stands for bidirectional forwarding and detection, and is a fast failure detection mechanism that tells the routing protocols when a path goes down. Uh, it takes typically milliseconds. Okay, it uses UDP ports 3784 for standard BFD control packets in a single loop or directly connected sections. Uh, it uses also UDP port 3785 for bridge forwarding and detection echo packets that is used for very fast detection, testing, and the data plane forwarding path. It uses also the port 4784 for BFD control packets, but this port it's for multi-op sessions like the multi-op external BGP, tunnels, overlays, and I don't know anyone more. Enough of talking, and let's start creating the or doing the configurations on the Palo Alto side. For that, we are going to create a profile with the mode active. That is our Palo Alto. It's here. Okay. So let's create the profile. Set network profiles, bridge forwarding and detection profile. Uh, let's give him a name. BFD BGP fast. It's a nice name, fast. We are going to say that it is active. We are going to say that it will have the minimum transmission interval of 200 milliseconds. It will have also a minimum receiving interval of 200 milliseconds. And we are going to say that the detection multiplier will be 5. What does this mean? This means that BFD will send and receive echo packets, as I have told you before, and we will have a detection multiplier of 5. What does this mean? We have set the minimum transmission and receiving intervals for 200, and 200 milliseconds multiplied by 5 gives a second, 1000 milliseconds more or less. So when the protocol BFD sees that a second has passed and we can't send or receive packets, the session will drop, and we don't have to wait all that time that we were waiting in the past. Now we need to enable the BFD for the BGP on the virtual router for the neighbor. So set network virtual router behavior protocol BGP peer group MikroTik peer. Let's say the name of the peer, the IP 123.32.23, and we are going to say that the BFD profile will be our BFD fast. BFD BGP fast. Boom, done. Now, what do we need to consider more in order to these to work? We need to understand that Palo Alto is a firewall, and the Palo Alto firewall needs to allow this traffic. So we need to create a security rule to allow the bridge forwarding and detection packets. So let's do it. Set role base security rules, and let's give him a name. Allow bridge forwarding and detection from Palo Alto to MikroTik. And we are going to say that this travels from the zone Palo Alto to MikroTik to the zone Palo Alto to MikroTik, and the application will be bridge forwarding and detection. The source will be any source for the sake of the configuration process. Destination, but we can filter these in the future if we want, okay? And we can say that the source is only the Palo Alto address on interface Ethernet 1/3, and the destination is the MikroTik address on the interface Ethernet 3, but for now we are going to say only any. We don't should do this in production, but it is just for a laboratory, so it's safe for me to do this. So destination any, our service will be application default, and our action will be allow. Okay, we are done with this. Let's do a commit. And after the commit is done, we can try to see the BFD details, but I want to say something before. BFD, it's like the tango. It needs two to the dance to happen. So what will happen is that after this configuration is applied on the Palo Alto, and it is finishing right now, if we go to the MikroTik, probably we are going to see this E from established disappearing. Okay, let's do it. Let's see it. Oh, it takes time. Let's see if it can ping 3.3.3.4. No, well, we can ping it. Weird. Let's verify the BFD details on the Palo Alto. Show. Oh, Sexit is good. Sexit. Show routing BFD details. Okay, we are seeing that it is in a down state. Okay, our BFD it's not working because it is not configured on this side. Oh, let me see. What route do we have here? Okay, it is working because we know the route via static. Hmm. Okay, let's continue our tasks, and we will try to understand these later. I don't believe that the MikroTik automatically recognize the BFD, so it would show up. It's not receiving, but it is sending. Okay, and as it is with the mode active, maybe it's for that it's working. But let's see. Show routing protocol BGP peer name and our MikroTik, and it has the session established. Show counter global pipe match BFD. Okay, we only have transmitted packets. Very well. Let's configure the BFD on the MikroTik side and see what happens. Routing BFD configuration add. Let's say that our interface is the Ethernet 3 and the minimum transmission interval will be 200, and also the minimum received interval will be 200, and our multiplier will be also 5. Okay. These must match in both sides, because if we have MikroTik sending minimum transmission intervals of 300 and minimum received intervals of 200, this will not match with the Palo Alto, and there will be issues regarding flaps on the BGP process, from active to idle to connect, and also to established when the transmission intervals match. But take this in attention, okay? The tango must be danced with the two devices. So let's check um, routing BGP sessions print. It's established, but we need to configure the BGP process on the MikroTik to use the BFD. So routing BGP connection, set our process to the Palo Alto peer, and we are going to say use BFD yes. And where it is, connects provider, Palo Alto, it's here. Where is the use BFD? It's here. Okay. Now we have here the use BFD. Okay. Now what can we do? We can check the BFD configuration, routing BFD configuration print, and you see that it is configured. Okay. Let's see the sessions for BFD and let's print them. Okay. We have the U, that means that it is in an up state. So now if we go to the Palo Alto and we do the same, we are going to see up. It is up and running. Okay, which is nice, and it is what we wanted to. Now we can test the BGP convergence and see that it is supposed to be more or less 1 second. So for that we are going to disable again the interface on the MikroTik. But before we do this, we are going to put in place here the show routing protocol BGP peer name, and our peer name is the MikroTik, this one, and let's see. Show routing protocol BGP peer name. What is happening here? Ah, okay. I was missing something. I don't know what. Okay, but the process is established for 149 seconds. Okay. Still established. So now let's disable it. And now you see established. Oh, this is taking a long time. Something is wrong here. This should say down. Hmm. It is not working. Why isn't it working? It took a long. This is not normal. I'm sorry, guys. It should took less than this time. Let me see if I made any mistake. Routing, BFD, configuration, print. Why does it say 3 minutes and 20? Routing, BFD, configuration. Edit. This is wrong. This should be 200 milliseconds. Maybe it's here. Why is it saying that it is 200 milliseconds? Let me configure it again. add interface Ethernet 3 minimum RC RX 0.2. Oh, we need to say 2 milliseconds. Okay, always learning, guys. Okay. This was the why it wasn't working for Hmm. Let me do this again. Sorry for this troubleshooting, guys, but it is required. So let me add again, add interface Ethernet 3, minimum receive it. Oh, I need to put my PC to charge. Sorry, just a moment. Okay, where were we? Minimum receive it 200 milliseconds. Minimum transmission 200 milliseconds. And our multiplier hits 5. Let's see if it is okay right now. Okay, now I believe we are good to go. Let's do the same test again. I don't know if the interface is up or down. Let me see. Okay, it's down. Let's put it in an up state. Interface set Ethernet 3 disabled. No. So now we have our BGP process established, as you can see. Let's see. We don't have, where is it? The BFD. The BFD is up. Okay, let's see it here also. What was the command? Routing BFD configuration print. Okay, the corridor. No, routing BFD session. BFD session print. Okay, now we are okay. Let's do it again. Let's put the BFD process in a down state. And let's put here the command. We can say match this to the peer group. Peer status. Okay, so let's cross our fingers, guys. And when we do the disabled here, and we do show it's on an idle state. Ta-da! Very good. So this was what we were trying to see. The BGP process went to a down state immediately, um, and it is what we need to so that we are not with the routes uh, on the routing table that don't work. Ta-da! Active and wait for it. Established. Dun, 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 dun. My friends, this is what I had figured out for today. We are on 51 minutes of configurations. I want to appreciate all your time and consideration. Uh, I will reserve one more lab for you for this series of the BGP. I hope that you are enjoying and that this is helpful for you, for your day-to-day basics, for your understanding of the protocol. For me, it is being amazing. I have learned a lot in these 100 days, and I want to say thank you to you all that are following me on LinkedIn, on YouTube, and that are exchanging message. Um, Stay in touch and have a nice day.